Hello, today I'm going to talk to you about Boolean operators and how they can be used to optimize your database searching. Now, if you've never dealt with logic models or computer science, you might be wondering, what are Boolean operators? Simply put, Boolean operators are a function used in search engines and databases to join search terms to either broaden or narrow down your results. Using Boolean operators can help you save time in finding relevant research, and using them to limit your results will also save you a lot of energy. There are three Boolean operators: and, or, and not. We're going to walk through each operator to learn why it's used and when it's used. The first operator is and. And is used to join separate keywords or concepts together. This tells the database that all of the listed terms must appear in your search results. For example, when we search mental health in college students, the database interprets that and knows that all search results should have some mention of both mental health and college students. The second operator is or. Or is used to factor in synonyms or other ways terms may be used or referred to. This tells the database that some keywords or key phrases can be used interchangeably. If we try the same logic that we used on the previous slide but swap out and for or, that tells the database that only one of the key terms, in this case mental health and college students, should be present in results. However, if we're looking for articles that mention both topics, we don't want to use or in this case. Let's take a look at an example of when using or would be more appropriate. We know we want to have our results include sources related to both mental health and college students. Where we can use or is to then expand upon those concepts and think of some synonymous terms. For example, undergraduates is another way that college students are referred to in research literature. In this case, using or is great. It tells the database that articles could be used if they refer to undergraduates or college students, but both terms don't need to be present in our results. The last Boolean operator is not. Not is used to specifically exclude stated terms or concepts from your search results. This can be helpful in avoiding distractors that are beyond the scope of your research. For example, if we're wanting to find research done about college students and we're trying to specify the setting, we could do that by saying colleges, not community colleges. This means all search results will exclude any sources that mention community colleges. Now, I wouldn't be a good information steward if I didn't provide you a word of warning when using not. It can be helpful to use not in some cases. For example, those conducting high-level evidence syntheses like systematic reviews may use it to tailor their results. But if you're not careful in how or when you use not, it could lead to you missing out on or skipping relevant sources. Let's take a look at an example. To see what articles were being filtered out when using not, I did some search testing in one of the library's databases. This is a complicated process that the average college student wouldn't have much need for, so for the sake of simplicity, I won't go into heavy detail of how that's done. Essentially, I ran a search that compared two search strings. One search that included all of our college terms, including community colleges, and one search that specified not community colleges. The search results that appeared shows the list of articles that were excluded by using not community colleges. One of the hundreds of articles that had been filtered out using not was the article pictured below. Looking at the title and abstract of the article, it seems that this would be relevant to our interests of articles discussing the mental health of college students. However, because one of the test groups in the study included community college transfer students, this article was excluded from our search. Instead of using not to exclude terms from your search and consequently missing out on relevant sources, try being more specific with your ands and ors to hone your search. Additionally, you can use the database's filters to narrow down your search results further. Before we're ready to search with our Boolean operators, there's one last piece to the puzzle. You may recall discussions of order of operations in math classes, where the parentheses come first, followed by exponents, and so on. Databases, much like mathematical operations, need to be strictly told what order to run a search in. Specifically, the database needs to first be told which terms can be interchangeable, i.e. the ors, by using parentheses. Then, outside of the parentheses, we can join together our ands and nots. If we don't nest our search terms from the previous example, our search yields 127,000 results. This is because the database isn't sure what order to run the search in, so while there may be some relevant results, there will also be several irrelevant results. The database could easily misinterpret the terms above to search for college students or mental health, which isn't what we want. If, however, we nest our like terms in parentheses, the database is much more able to run the search as intended. And in this case, we cut down the results to 12,000, which is still a high number of results, but a lot more manageable than 127,000. You'll notice I also nested the other terms, despite not having any synonyms added to them with or. This is to show that if we wanted to flesh out those terms with synonyms, we could. And in that case, those would need to be in parentheses too. Another way of visualizing Boolean search operators is using the Venn diagram. Think of each search keyword as a circle in a Venn diagram. In this case, mental health is the yellow circle, and college students is the blue circle. When we run the search mental health and college students, our search results will only be including sources that fall into the green area, where there is an overlap between both terms. This is because we are searching for references that must mention both keywords. If we run the search mental health or college students, our search result will fall under all three colored sections, the blue, yellow, and green. This is because we've specified the results only need to include one of the terms. It's possible that some results may include both terms, the green, but also the blue and yellow sections will appear. Finally, if we run the search mental health, not college students, our search results will only include sources from the yellow section. This is because we've specifically asked to exclude sources if they mention college students, which means even sources in the green section will be missed, even if they do mention mental health. If you're interested in learning more about Boolean operators or want to hear more examples, feel free to contact the library. You can contact the library by either calling 610-796-8223 or by emailing us at alvernia.library@alvernia.edu. Thanks for watching.